Okay, so we're going to call this salts and ionic bonds. Do you remember when we were talking about the periodic table, we said that francium was the king of all metals? Yeah? Francium is great at giving up its electron because its ionization energy is really low, right? That's why it goes kaboom in your face when you drop it in water. Who did we say was the perfect match for francium? Fluorine. We said fluorine was great for francium. While francium is really good at giving up its electrons, fluorine is great at taking them in because it's got a lot of protons and not a lot of shells to get in the way. Okay? So these two are perfect for each other. So let's write that down. So alkali metals and halogens are perfect for each other. And when I look for an alkali metal in nature, 9 times out of 10, who do I find it with? A halogen. All right, well, I'm going to show you why they're perfect for each other. And I'm going to use something called a Lewis dot structure. I'm going to use this Lewis dot structure to teach you how to draw something called a mechanism. And mechanisms are things that are particularly important when you get to organic chemistry, if you ever take that in college. Okay? All right, so let's start by drawing the Lewis dot structure for lithium. All right, so for the lithium atom. The way that you draw a Lewis dot structure is you write the symbol for the element, and then you draw dots to represent the number of valence electrons that that particular element has. So how many valence electrons does lithium have? 1. I made you write it on the top of your periodic table, right? Okay. So I'm going to draw lithium with 1 dot. All right? And now I'm going to draw fluorine. How many valence electrons does fluorine have? Has 7. Now, put your pencils down and watch. Some books tell you to draw the 7 dots like in a circle, right, to go clockwise. And you put 1 dot on each side first before you partner. I don't want you to do that at all. I want you to do this in a cross pattern. All right, so again, put your pencils down and watch. First dot, second dot, third dot, fourth dot, fifth dot, sixth dot, seventh dot. Okay? So I'm Catholic, so it's easy for me to remember this because I think of crossing myself, right? So 1, 2, 3, 4, 1, 2, 3, 4, right? And there's a reason why I want you to do it this way, okay? All right. Why don't I want you to go clockwise? How some books show you to do that. Well, if I put 2 dots on fluorine and I don't do this clockwise, think about this. What's the charge on each of those electrons? Negative. Is that as far away as they want to be from each other? No. 2 negative things are going to want to repel as far away as they possibly can. And 90 degrees is not the furthest they could be. What's the furthest they could be? 180. So it really would be best if you had 2 electrons to lay out if you put them at 180 degree angles from one another. Okay? Now, why am I making you put 1 on each side first, 1, 2, 3, 4, before I partner? Because what is that rule called? What rule am I trying to apply here? Remember I had a name? Yeah. I'm trying to also apply Hund's rule, right? Where you put 1 arrow in each box in the alpha diagram before you partner them up. So that's why I like to go in that cross pattern. So up, down, left, right, up, down, left, right. Now, if you don't want to do it up, down, left, right, and you want to do left, right, up, down, that's fine too. It doesn't matter. Okay? Just do it in a crosswise pattern. All right, now, I'm going to cross these out. I don't need those. This guy happy? Oh no, it's miserable. What's wrong? It has 1 valence electron. How many does it really want? It could either gain 7 or lose 1. What does it want to do? Lose it. Okay, guess who's going to lose it to? Fluorine. Why? Because fluorine wants 1 more, right? So this business of drawing arrows to show the flow of electrons from one atom to the other is what we call a mechanism. It's a picture that shows how the 2 atoms are interacting with one another. And organic chemists love to draw these things because it explains how organic reactions occur. And the atoms are interacting through their electrons. Okay? All right, now, when lithium gives up its electron, it becomes an ion, right? So let's go ahead and draw the dot structure for that ion. Okay, so I'm going to write lithium. Do I draw a dot around it? No. How come? Because I gave it away. And then, so that the person looking at the picture knows that I have given electrons away, I'm going to go ahead and write lithium in a square bracket, and I'm going to put the charge in the corner so that they know that that lithium gave away one electron. This is what forms after that electron moves over to the fluorine. All right? How do I draw the fluorine ion? Actually, it's not called the fluorine ion, it's called the fluoride ion. I write F. How many dots do I put on it? 8, because I'm going to draw it with the dots, with the extra dot that I got from the lithium. And again, so that the person looking at the picture knows that I messed with the electron number, I'm going to draw it in square brackets, and I'm going to put the charge in the corner. Okay? All right. Now, what I've essentially created is two little magnets. One having a positive pole, one having a negative pole. And if two little magnets of opposing signs are next to each other, what do? They magnetically attract. So I'm going to basically draw that with a little dash line. So there's a magnetic attraction that forms between the positive and the negative ion. Does anyone know what it's called? It has a really common name. It's called an ionic bond. Because it forms between what? Ions, between two ions. All right, so what kinds of elements form these ionic bonds? Well, what was lithium? A metal. What was fluorine? A nonmetal. Ionic bonds form between metals and nonmetals. And compounds that form ionic bonds have a very generic name. They're called salts. Yes, sir. Yeah. Uh-huh. Yeah, if you want to, you can. Yeah. When I say the word salt from here on out, I'm not just talking about the stuff you sprinkle on your food to flavor it. Okay? I'm not talking about NaCl. I'm talking about any substance that has an ionic bond in it. So CuCl2, AlCl3, MgF2. All of these substances made between a metal or a nonmetal are categorized as salts. The word salt is a generic term. Okay? Are we good with that? Now, lithium and fluorine are great for each other, right? But what about magnesium? Magnesium is a cousin of lithium. What if magnesium and fluorine bonded together? Can they? Oh, yeah, they can. Of course they can. Well, let's start by drawing the dot structure for magnesium and showing how they could do it, right? So let's do the atom for magnesium first. So again, we write the symbol for Mg. How many valence electrons does the magnesium atom have? 2. So I'm going to draw the 2 dots, one above, one below, right? And then I'm going to draw a fluorine over here. All right, how many valence electrons does fluorine have? 7. So let's draw the 7 dots on it. Is magnesium happy? No. Is fluorine happy? No. Can they do something for each other here? Yeah, what can magnesium do for fluorine? It can give one of its electrons, right, to fill that fluorine. Now fluorine's full, but what do you notice about magnesium? Is there a problem here? It still has one electron to give. So how do we fix this problem? Bring in another fluorine. Excellent. All right. Okay, so when magnesium gives up its electrons, we have to draw it as an ion. How many dots do I draw now in its ionic form? None. I put brackets around it. What's the charge that I put in the corner? 2 plus. And then the fluorine over here on the left-hand side, again, I draw it in brackets with a 1 minus charge. And how many dots do I place around it? 8. 1, 2, 3, 4, 5, 6, 7, 8. Where do I put the second fluorine? Do I put it next to the first fluorine? How come? Why can't you put two negatives side by side? They repel. So the other fluorine I'm going to put on the other side of the magnesium, and this is really important. When you draw these dot structures for the ions that form, you always want to alternate the signs of the charges. You never put two positives side by side. You never put two negatives side by side. You want to do negative, positive, so on and so forth. All right? Where's the ionic bond? Well, there's one here, right, between that fluorine and that magnesium, and then there's another one over there. Let's see. You guys are smart. What's the formula for magnesium fluoride? Mg F2. That's the formula for magnesium fluoride, the compound that forms between magnesium and fluorine. Well, how come? How come you do that? Because what does the picture tell you? You need to have two fluorines around to satisfy one magnesium. Okay? Let's do another one. One more picture. What if aluminum wanted to get in the game? What if aluminum and fluorine bonded? Well, let's draw the picture out. We're going to start with the atom of aluminum. How many valence electrons does it have? Aluminum, how many valence electrons? 3. So 1, 2, 3. And then I'm going to draw fluorine over here. Again, it has 7 valence electrons. Is either one of these atoms content? No. So what's aluminum going to do? Give one of its electrons to fluorine. Now fluorine is full, but we still have an issue, right? What's the issue? Aluminum is a giver, right? Is aluminum done giving? No. So what are you going to do? Let's bring in another fluorine. Are we still done? No, let's bring in another fluorine. And so we're going to end up making the aluminum ion, right? Which I'm going to draw in square brackets with the charge in the corner with no dots around it, surrounded by fluoride ions that have 8 dots around them, a charge of -1. And I'm going to put the fluorines in a way where I'm trying not to put the 2 fluorines side by side. All right? So, give me a second, Jennifer. What is the compound? What's the formula for the compound that's made between aluminum and fluorine, what we call aluminum fluoride? What's the formula for this compound? AlF3. Yes, Jasmine, what's your question? Mm-hmm. What do you mean? If you want to, but when you're doing 8, it doesn't matter. Right? Because you're just filling up all the dots all over. Okay. All right. So the second half of homework that you have tonight is going to be things like this. You're going to have to draw mechanisms to show how ionic bonds form between certain elements. Okay? Now, tomorrow, I'm going to show you how to come up with these formulas without even have to draw these pictures at all. I drew these pictures on purpose to help you understand the whys and the hows. But at the end of the day, that becomes really tedious after a while, right? So I will accelerate this process significantly tomorrow. All right? Any other questions? Great job today, guys.